So Liz Keogh told me how cool approval testing was like ages ago and how I had to know about it. And now I'm going to know about it, and so are all of you. So yeah, this is Emily. We're really lucky to have her here. Please welcome her.
Thank you so much. I didn't put approval testing in the title in case it put people off, but this is a talk about approval testing. But more than that, it's about how to handle a situation which I think a lot of people are in, where you've got legacy code and you need to have tests for that. And so that's kind of what this is about, really. So I'm guessing that you're going to recognize this situation where you've got this large, complicated code base, but it's really valuable, it's in production, people are using it, and it's earning money for your company, so you can't just ditch it. But developers find it difficult to work with. And so I've got this picture here of this big chest of drawers. It's an essential piece of furniture. I'm sure you all have one in your houses. But if you're honest, you may not actually know everything that's in it. You know, isn't it a bit like that with legacy code? It's essential. You've got one, but you're not entirely sure everything it does. And it might be a little bit messy inside. So we'd like to actually, at some situation, kind of get control of this so that we can get the most value out of this and add features and earn even more money from our legacy system. So when I say it's a bit messy inside, I'm talking about this analogy people often talk about technical debt. And I like this description from Martin Fowler of what that is. This is deficiencies in the internal quality that make it harder than it would ideally be to modify and extend. The state of the code is slowing down development. It's like this guy with the weight on his foot. He can't move very fast. You can't be agile in this code base because it's poorly designed for what you're trying to do with it. So we need to keep this technical debt under control. And basically that means you need to invest in some restructuring, some refactoring, some improvements in the architecture, upgrading stuff, and that will hopefully then get you moving again. The trouble is, before you really feel confident to do all that restructuring, you'd like to know that you didn't break anything. And for that, you probably need some tests. So automated testing is another topic that you may know something about. And I've got a little survey. So let me just see if I can bring up the survey here. I thought I was going to go high-tech here and not just have you raise your hands. So if you've got your phone and you've got Wi-Fi, you can go to menti.com and type in this number, and it will present you with my survey. And then when you fill it in, hopefully you'll see the results coming up here on the screen. So a few of you have got mobiles in your hands. That's looking hopeful. So what are your biggest problems with automated testing? This is some things that I have seen as part of my work that I thought maybe you'd recognize. So basically, maybe you have no tests. Maybe you just have a few and they're not covering much. Maybe the code is just difficult to test. Or maybe you've got some tests, but they fail all the time. Maybe you're just finding that the test maintenance costs are so high. Or just you've got the tests, but they're just really slow. Or even you've got a bunch of tests, but they're using so many mocks, they're actually stopping you from improving the structure of the code. That's a particularly nasty problem, I have to say. Okay, so we're getting some answers here. Some of you have managed to find the Wi-Fi. That's good. Oh, cool. Well, so I don't know how many people are still going to answer, but there seem to be some early results coming up here, that most people have at least got some tests, so there's not many for the first option there. And the most popular option is that the code is difficult to write unit tests for. But all these problems are coming up, actually. We're looking at this. Yeah, so definitely the code being difficult to write unit tests for is a very common problem. So I'm glad you're in the right talk. If you've got these problems, I'm hoping that maybe approval testing can help with some of these. So let's see if we can talk a bit more about this. So this is the thing. If you haven't got a legacy system or whatever, any system actually, the typical advice is the testing pyramid. This is Martin Fowler's picture of it, where he says, basically, you've got to have loads of unit tests because they are fast and cheap. And you can have a few full stack tests through the UI, but they're slow and expensive, so you can't afford to have very many. And then there's all these kind of tests in the middle that are just kind of called service tests. And everyone who draws the test pyramid kind of seems to put something else in the middle there. And that's, I think, because the original description of the test pyramid was actually pretty vague on this point. But it's that middle part of the pyramid that I think is the one you really need to look at when you've got legacy code. And the thing is, exactly what you need there depends a lot on your architecture. So that's kind of why I chose this title about architecting for testability, because you want to have an architecture that will support some tests in the middle of the pyramid, in my opinion. Because the thing with unit testing is that for the legacy code systems, they don't have unit tests, and and they don't have units. I mean, that's kind of a typical situation that it's not been designed with testing in mind. And you can kind of use a lot of mocks to extract units. But then you run into the other problem that you've got lots of unit tests using mocks, and they get in the way of refactoring. They're stopping you from improving that structure. And they also don't find bugs very much, because most of the time you're just checking that the mocks were set up correctly. So writing unit tests for legacy code is hard, and honestly, I wouldn't recommend it. But then the other end of the pyramid, the end-to-end tests, they are slow, they're expensive, as Martin Fowler points out, but they do find important issues. And this is why a lot of companies fall into this trap of investing a lot in them, because they do find stuff. And that's important. When you're changing the legacy code, you need that safety net. And then they just end up having very slow, expensive tests. So I think there must be a better way. So this is where I think basically it comes down to we need to talk about architecting for being able to test it in that middle layer, where there are not that many good testing tools and frameworks aiming at that middle layer, because it's aiming not at testers, because testers usually test the whole stack, and it's not aimed at developers, because developers do unit tests. And the market for that middle layer of the pyramid, I'm not seeing a lot of tools targeting it. And I don't think that a lot of architects really think about testability. So that's kind of why I wanted to give this talk, really, because I think there are some tools, and they're not very well known. And these are some of the ones that I know of that are approval testing tools that I think work well in this context. So I'm going to say a bit more about them in a minute, but I wanted to show you a demo of one of them. So let's go now, of course. This is the problem, because I can't see the screen at the same time. I'm going to have to stand over here and not face you. Okay. So I have recorded a video of myself, and so I can talk rather than type. Okay, this is some code. I hope you're all right with code. I'm going to take you through it, and it's only a 5-minute demo, so if you're scared of code, it's fine. You can code for 5 minutes. So this is a test case written with an ordinary unit testing framework in Java. And it's the domain here is a supermarket. It's a code kata, but it's a supermarket. So you can see this test passes. So what we do here in our 10% discount test is that we construct ourselves a catalog of products that we're going to sell in our supermarket. It's a fake. It's a test double for testing, but don't worry about that. It's supposed to imitate a real catalog. And I've got a toothbrush and some apples that I put in my catalog. Then I go to the cash register, which I'm telling that we've got a special offer this week, 10% discount on toothbrushes. Okay, and then we've got, oh yeah, there we are, 10% discount on toothbrushes. Then we get our shopping cart, and we put some apples in it. So we're not buying any toothbrushes, just apples. And then we've got, so that's all the setup. And then the act step is that we're going to go and go to the cashier and buy the stuff, and we get back a receipt. And then we've got the assert bit where we're going to check that receipt has got all the correct information on it. So we've got, the total price is right, and the item price, and the number of items, and no discounts, and all that kind of thing. So if you notice, that's actually a fairly large chunk of functionality for a unit test. And I've got a lot of assertions. And the classic unit testing advice is, no, that's too big a chunk. Test a smaller piece. You only should have one assertion. I am not writing unit tests here. This is a middle of the pyramid test. Because it's legacy code, it doesn't have smaller units. This is actually kind of the smallest bit of unit I could really kind of isolate. So there we are. I've got this test. And I'm going to rewrite it using approvals. So approvals.verify, and then I want to give it as an argument the receipt, but not just the receipt object. The approvals.verify takes basically a string. And I need to somehow convert that receipt into a string that I can pass to approvals. So it just so happens that I've got a class called receipt printer that I can pass the receipt to, and it will print it and lay it out nicely. And in this repo, I've put it with a production code, but I regret that now. I should have put it with the test code, because this is code I've written for testing purposes. I think I'm just going to show it to you. It doesn't do anything very complicated. I get a string builder, which I basically append to. I go through all the fields in the receipt, and I just append the information about what was in them to the string builder and return it at the end. So I go through all the items on the receipt, all the discounts, the total, and then just return the string builder. So I'm going to run this test again now. And if you remember, last time I ran it, it passed. Now it fails, and that's because I added this verify with the approvals. An approval test, certainly with this framework, will fail the first time you run it, because it needs something to be able to compare against. And because I only just wrote this, it doesn't have anything to compare against. If I look at the error message, it kind of says, failed approval, this approved file there didn't match this received file here. And that's because there wasn't an approved file. It was empty, so of course it failed. But I've got the received file. You can see it's put it on disk here, just next to my test case, and it's named after the test case, .receive.text. And there is it. So that's what my receipt printer has printed out. I bought some apples, if you remember. And then this is all the details on the receipt about what I bought. So if I just rearrange my windows so that you can see the assertions I had before next to my receipt, printed out receipt, you can see that all the stuff that I was asserting before is printed on my receipt. So everything that I was checking before in assertions, I'm now checking in my printout. So if it was going to fail before because one of the fields didn't match, it's going to fail still with the approval not matching. I'm just going to check basically all the values I'm looking for are still there. And so this looks good, it looks correct. So this is the crucial step with approval testing, when I approve that result. And in this case, with this framework, I do that by renaming the file. I rename it to .approved.txt. I approve this. That looks correct to me. So now I run the test again and it passes, because it found the approved file and it matched. So I can delete all those assertions that I had before, and I've now converted my test to use approvals. Now, the eagle-eyed among you will realize that my test actually is named pretty badly, because it doesn't actually check the 10% discount, because I didn't buy any toothbrushes. So I'm just going to take the opportunity here. I'm going to duplicate this test and rename it to no discount. And then I'm going to actually buy some toothbrushes so that I can see the 10% discount. So I've got to buy just 2 toothbrushes here. So my 10% discount test is now buying toothbrushes instead of apples. So if I just run this one again, it fails. It should fail. There we go. If you're lucky, it would bring up the diff window automatically, but here I'm just opening it for you. So you can see the test failure is really clear. I was expecting this receipt, I got this receipt. And you've got this diff merge window to inspect that and work out, is that what I wanted? Do I approve this new result? And I'm looking at this and thinking, yeah, that looks right. So I want to approve that. So I'm just going to use the diff merge tool to merge all the changes into the approved file so that they're identical. And then that test will now pass with a different approved result. Of course, you use version control to make sure that when you approve stuff, you can see who did it, you know. And if you're lucky, they'll write a commit message that tells you why. So yeah, so that I approved a new result. So that I just wanted to show you the other test now that I've got, the one that's called no discount. I haven't run this one before. It's effectively a new test. And I get a new receive file, and you should recognize that from before. So I'll just approve that by renaming it. So now I've got 2 approval tests. And if you've been watching closely, you saw me duplicate the entire test case. So I've got a bunch of duplicated code in the arrange and the act steps. So the next thing I'm going to do is just clean that up and create a setup method and mean that I don't have all that duplicated code. But this is a talk about approval testing, which is actually really about that last part of the test. So I'm not going to demo all the fixing the duplication between the 2 test cases. Yeah, so I was going to do the survey now. I want to know your initial impressions. So, because when I talk about approval testing, people are like, well, what's that? But then they see it and they realize, actually, I've used that kind of approach before. I recognize it. I didn't know what it was called, or I called it something else. And then the second thing is, would you recommend this? Have you had good or bad experiences with this kind of testing approach? So if you have done this, what do you think? I'm interested. Okay, we've got a few responses. Just see if everyone else will. Okay, yeah, so we've got a few responses there. And yeah, so lots of people have actually seen this before, kind of. You may have heard it called characterization testing, or golden master testing, or snapshot testing. Those are all basically very similar approaches. I think the name approval testing is the best name for this, so that's why I call it that. And lots of people would actually recommend it. Oh, interesting. I haven't asked that before, so I was kind of half expecting some people to say, I tried it and it was terrible. I would never recommend it. But I didn't see many, maybe one person has said they wouldn't recommend it. Yeah, interesting. Because if you do it badly, it can be really painful and really expensive. So maybe you've had some good experiences with it. Okay, so that's interesting. So I'm going to just go through the theory a little bit. Now, unit testing. I'm hoping you're familiar with the idea of the test having 3 parts: arrange, act, assert. And the test that I started with certainly had those 3 parts. But then I converted it to an approval test, and I added actually 2 more parts and removed the assert. So arrange, act, the same, and then I had print, and then diff. So the print step formats the results from the act step as a multi-line string, and the diff step will diff it against the approved output, assuming there is one, and if there isn't, then it fails. So when a test fails, you inspect that failure by looking at the diff between what you have and what you approved previously. And in my experience, this makes your test failures really readable. You've invested in a printer that will lay out your domain objects in a way that is logical and presents that information in a way that's readable and multi-line, so that every line is effectively an assertion. But you see all the context, you see all of the assertions and all of the results at once. And for me, this makes your failure really communicative of what's going on, which I think is an important factor for having lower maintenance costs. So then the other part you needed to do, though, was design this printer. And this is, as I say, pretty crucial for making those failures understandable. So I showed you in this demo a hand-coded printer. But if your output is already JSON or XML, you can probably get away with writing very little code and just formatting that with some indentation. And that can be a cheap way to get going with this. And it could be actually even cheaper than writing your own printer. Although I have to say, if you do write your own printer, you have full control and you can really maximize the readability. So I would recommend approval testing for that middle chunk of the pyramid. Anything that's bigger than a classic unit test, any time that you feel that you want more than one assertion, that the test failure is just going to be so much more readable with a diff rather than a bunch of assertions. And you hopefully will end up writing less code overall because you can reuse the same printer in several tests instead of writing new assertions in every test. Yeah, so that's what I've been trying to sell this to you. It's if you use these kind of approval testing tools, hopefully you'll have lower test maintenance costs, higher bug finding potential, but you do need good tools. You need an approval testing tool. I don't think you should roll your own. Don't build your own tool to do this. Use a tool that exists. These ones are all open source and you can contribute if they don't have the features you need. And there may be commercial ones as well, but I'm not so familiar with that. Okay, so I've just kind of introduced approvals. I want to do another demo. Now, where am I going with this? This is my other demo. So I just showed you like something that was almost a unit test. It was just a little bit larger. Here I'm going a step larger again. I'm going to demo approval testing a microservice. Yeah, let me just... So this is on my Git, and I forked it from Mark Winteringham. So I'd have to do, I just showing you the basic procedure. I got the code off GitHub. I did npm install. It's a node microservice using MongoDB in the back end, and it's npm install, npm start, and the thing is up and running on my local machine. It really should be that easy. So now I should be able to go to localhost on the right ports and see the application running. And here it tells you all about this thing. It's Mark Winteringham created it as an API testing playground for testers to learn about API testing. And I thought this was a cool idea to see if I could test it using approval testing. And so I forked it and to show you how to use text test, which is another approval testing tool that I'm one of the contributors to. Actually, I contribute to approvals.java as well, but yes. So I wanted to show off text test because it's suitable for larger things. Approvals is pretty good for like nearly unit tests. Approval and text test is better for larger things. So I'm going to show you how to test this thing. So you click here and it shows you the documentation. On this side, it's got the list of all the endpoints that there are. And if you click on the endpoints, it shows you the documentation about how to access that. So the simplest endpoint is the health check. It's ping. It shows you if you access that, it should come back and tell you. Yeah. So if you curl this endpoint, it should come back with a 201 created. So let's just try that on the command line. I curl that URL and I get back a 201 created. So it's just saying, I'm alive. So that's not a very interesting endpoint. Get booking is a slightly more interesting one. So this is one where you ask it, okay, give me booking number 1. And it does, it comes back and says 200 okay, and then there's additionally this bit of JSON you can kind of see there on the command line, saying I've got a booking for Eric Erickson. And yeah, details about his booking. So that's the other endpoint. So that's also, it's just a GET request to get some data. So those are the two I was going to show you how to write a test for with this thing. So now, before I can write tests for this microservice, I found I needed to make 2 modifications. So these are the architectural changes that I'm making to make this thing testable. Firstly, I needed to have an ability to control the database on startup, so that the data in there is completely under my control. I can tell it, this is your database. And then the second thing I needed to do is to add an additional endpoint so that I could query the internal state. I'd like to know at the end of the test what's in the database so that I can check that it did the right thing. Because this is, this microservice is all about updating the data in the database. And I need to be able to check that. So I want an under the covers way to get at what's going on inside. So I'm just going to skip over the part where I do that. It's maybe 100 lines of code. It's maybe a bit less. So anyway, so that was the first thing I needed to do. The next change I needed to make was to write a test rig. So that's what I'm doing here. And this I'm writing a Python script. And I thought I'd just start with a Python script that just prints hello world. So that's what that does. So I'm just, I've got a file named test rig, and all it does is print hello world. So that's just like my first iteration of my test rig. So the next iteration is going to do a bit more. I'm going to have it start my server, my microservice. And then I'm going to do one request response. And then at the end of the test, I'm just going to stop my server. And then the only other little thing I was going to show you here was actually, I want to be able to run lots of my test rig in parallel. And I'm going to do that by partitioning by port. So if I find a unique port and run it on that port, then I can run lots of these in parallel. So each one is going to start the process with its own copy of the database on its own port, do one API request, and then stop it. Then there's the rest of the test rig that I'm going to skip over. I was hoping you could understand that much of the code. But there's the rest of the test rig. I'm also going to have it read from disk the initial data to put in the database, and also read from disk what endpoint I want it to access. So the test rig is going to look for a file in the local directory that tells it, put this in the database, and then it will call the API and shove that in the database. And then it will call the REST endpoint that I specify. And then collect the final contents of the database. So it's a Python script that kind of interacts with my service. And then I can connect that up with text test. So this window here that is in the middle of the screen is my test management window with this tool text test. And it's got a GUI because it's very convenient for managing tests. It has a command line interface as well, if you're not keen on GUIs. But honestly, this is convenient. So anyway, on one side of the screen, you've got a tree of tests containing one test case named ping. And on the right, you've got the specification of the test. And I'll go through that part more in a minute. But the basic idea is that I've got this REST command and and a database. So those are the two things that my test rig needed in order to run. So the database is just some JSON, and the REST command is just saying get/ping. And then I've got all these approved files. And now those are like the equivalent of that .approved file that we had in approvals, except I've got lots of files. Text test by default lets you have as many approved files as you like per test. And that's convenient, so I can put the HTTP headers in one file and the response text from the HTTP call in another one. Yeah, I'll come more to those in a minute. So when I run this test, it passes, which, I mean, that doesn't probably tell you very much. So I thought I would write you a new test for the other endpoint, for the get booking. So I used the GUI to say I'm going to have a new test called get booking, and it inherits, so the data files I need to define as well. So I've got a name, I need the initial database and the REST command. So the initial database, it's just told me, look, I've already got one that I was using for the other test. Shall I just use that? Okay. And then the other thing I need, though, is that REST command. So I'm just going to open that in an editor. And for this one, I wanted to do get booking number 1. And I realized I needed /booking number 1 for that to work. So now I've got, if you notice, there are no approved files here because I just created the test. So I haven't approved anything yet. So then I run this, and it fails. Of course, it fails the first time because there are no approved files. But it tells me, look, I got all these new files. You should have a look at them and work out if you can approve them. So here we've got, so what have we got? Response headers. So that's the HTTP headers. Honestly, usually they're not very interesting, and you may not even want to check them, but I'm just showing you could if you wanted. then you've got the response JSON. Now that is what I actually wanted to see. That is the booking that I got back, the JSON. I asked for booking number 1. That's booking number 1. So I've just laid it out nicely with a printer that just formats JSON. And then the HTTP status code of 200, which looks good. And then I've got standard out and standard error from my test rig. And standard error being empty, that's a good thing. If it had crashed, the test rig, I'd have got a stack trace there. And the test rig also just writes out a little log of what it's doing. So it says, I'm starting the server, I'm running this REST command, and I'm stopping the server. So all of that looks great. So I click the button. Oh yeah, there it was, the log. That looks great. So I click the big button that says approve. And now when I close this test run and go back to my test management GUI, there I've got all those approved files. So this will now also pass when I run it. There you go. So I'm not going to take you through creating all the other tests for all the other endpoints. I'm just kind of going to skip over that. But it's basically the same principle. I find some test data, I specify a REST command, and then I basically run it and approve stuff. So I don't know if you notice, while it's running, I've just paused it in the middle of running. It's running 2 at a time, because I've got 2 CPUs. It runs them by default in parallel. And it actually runs pretty quickly. I've got 8 tests. And it runs pretty quickly too, because this is a very small, lightweight little service, and starting it and stopping it actually goes very fast. And running them in parallel, you know, I can run the whole of these 8 tests quickly enough that I could actually use these to support refactoring. And even with bigger services, I've done it like this, and you can actually test a whole service like this. You know, it works. I'll come to that more. But anyway, I just wanted to also show you, I've got a test for, there's my get. These are all get requests. Create booking, that's a post. Post, and so of course I need to also post some data. So that's another data file that my test rig picks up and posts along with the to my API endpoint. Yeah. So it works not only for GET requests, and then I can see I got in my response, I got back the thing I posted, and then the final DB. So yeah, so that's the other thing. For this test, because it actually changed the database, I had it collect the final database, so I can check my new record is in it. So I think that's the end of this demo, pretty much. Yeah. So that's a demo of a slightly bigger test using a different approval testing framework. And yeah, that is the demo. So what was I going to do now? Yes, I was going to tell you about the overall strategy. So that was the kind of the demo, and I'm going to go through the theory. Because I think for a legacy code base, this is the kind of overall strategy. First, you need to isolate some kind of unit, and something smaller than the whole thing. Because Martin Fowler's right. Those end-to-end tests that we're going to test the whole chest of drawers, they're just too slow and too expensive. You need to find something smaller, perhaps the size of a drawer, that you isolate, you pull it out. You mean that I can test just this part. And that's the first part of the strategy, which is the part I'm just going to talk about now. So in this demo, what I had to do here to pull out this drawer, I had my microservice already with its database. I needed an additional API on it so that I could make it testable, so I could pre-populate the database and query the internal state. If this microservice had, or this part of your monolith had dependencies on other parts, you would like to, of course, replace those with test doubles. And you really want to choose where to draw that line that you're trying to isolate around the piece that has the fewest dependencies that you need to mock. You don't want more mocks than necessary. But yeah, so that's one thing, additional APIs. Then you need a test rig. And in this example, I had a test rig that would start everything, do one request response, stop everything, and it was using the testing APIs to interact with it. So for this part of my testing strategy, I needed developers involved People and architects probably as well. I had to make architectural changes to make this application testable at the level of, I want to isolate this piece, and I need to write a test rig. Possibly you also might need to write your own printers. Here I could just use a standard JSON layout, but you might have to write printers. So this part, you definitely need developers involved. And you need a bit of an investment, honestly, before you're going to be able to write any tests. But then the next part of the strategy is, of course, we're going to cover that drawer that we've managed to pull out with approval tests. So each approval test is going to run the test rig, but it's kind of data-driven testing, so I'm specifying each test case a different endpoint, a different DB contents potentially. And then I'm going to check what happened using diffing it against my approved files, so that it will show a diff on failure that I can actually understand and do something about. That's what I want. I want to see a diff that tells me what's happened when the test failed. So if I look back at this slide of the parts of the approval test, the arrange part of this test is just the data files. The act step is running the test rig. The printer, as I said, is just formatting the JSON outputs and laying it out with indentation. And then the diff is text test, kind of has functionality to help you to see that diff and to manage that diff. And yeah, there's actually a lot of functionality in text test, but yeah, that's what it's helping you with. So for this, writing these tests, this is where I think you need to get testers involved, because testers are really good at identifying the interesting scenarios that you're going to want to have regression tests for. Because these are bigger than unit tests, they do cost more than unit tests, so you can't test absolutely everything. You do have to be a bit selective about your scenarios, and that's where testers are really helpful, because they know how to do that. And of course, when you're designing printers, testers have a good eye for that. What is the important information that they want to see, and how can you lay it out in a way that domain experts are going to be able to read and work out? Because, it's one thing, usually it's actually developers and testers who are approving outputs, and they have a pretty good idea about what is okay and what's not okay. But it's even, if they're unsure, it's really useful to be able to go to a product owner or business analyst and say, can you look at this output? Does this look right? And have it be in a state that they can read it. So this style of testing really does need to be a collaboration, in my experience, between developers and testers. And then when you've got your tests in place, hopefully they run fast enough that you can use them to validate your restructuring, your refactoring, your rearranging the stuff in the drawer to be laid out in a logical way, so it's easy to add the new stuff that you want to put in there. So I've got this analogy with socks. My sock drawer is a mess, but I can kind of imagine how it could look. It could look like this. So this, you're refactoring to make it really easy to add that new functionality. And you've got these approval tests that will hopefully catch any refactoring mistakes. And they've got to be fast if that's going to work. So I just showed you, by default, text test run stuff in parallel. And if your local machine doesn't have enough compute power, I've done this also with a queuing system where I can, kick it off and it will go and spin up a bunch of other CPUs not on my machine. This was in-house, but I'm sure you could do it on the cloud as well. And then you can run, as many tests in parallel as you have CPUs available. And with this testing approach, I've had test suites of hundreds of tests running fast enough to support refactoring. But they're not all running on my machine. So that's kind of the general idea. I've got a few minutes more. I want to bring this up to another question for you. So I've showed you a couple of situations. What is your situation? What is your architecture? And I've just put up some options here that I think people have. So maybe people have a monolith or some microservices, or so I'm kind of interested. I think you can select as many of these as you want.
No.
Oh, is it only one option?
Yeah.
Oh no, I messed up. I was convinced I'd selected the, sorry, I wonder if I can update this while you're answering it. Let participants choose. Yes, that's what I wanted. Okay. There you go. Let's fix it, right. This is the first time I asked this question in a talk, so. Okay. I'll give you a minute to update your answers if it'll let you go back and update it. Yeah, okay. Yeah, so we do have a lot of people with a monolith. And a lot of people with a web front end, microservices, large database. Interesting. I guess that's the monolith people with a large database. And, reports in PDF and XML and CSV and REST APIs. Yeah, third-party services. Okay, so these are all interesting architectures, and the exact testing approach that you're going to choose, of course, depends on your architecture, which is why not many people, I think, stand up and tell you how to test, because it's different advice depending on what you've got. So I've got 3 case studies for you of situations that I've been in that I'm hoping will resonate with at least some of you. So the first system I'm going to talk about was a medical assays information system. So this one was about 15 microservices. It had been a monolith just a few years previously, and they were just splitting out pieces of it into microservices. With a web front end, several databases. But this is a screenshot of the GUI. It's in Swedish, but it's basically a medical assay, a blood test. So this is presenting the results of some fictional character and the results of their blood test. So the really important thing for this system was that the data being presented on the screen was correct and accurately reflected what was in the database. And if there was any corrupt data or inconsistent data, we wanted to see that on the screen. So we had to make some architectural changes to make this system testable. Firstly, we spent a long time stripping down so that we could run the system with a minimal data set. Initially, it needed an entire production database, but we spent a long time just saying, okay, if I take this data away, what breaks? Okay, I better fix that. So eventually we found a core set of data that we absolutely needed that was small enough for testing. The other thing, we made sure that we could deploy the full system locally. Only 15 microservices, actually you could get that all up on one developer's machine. And then we invested in making it really fast for the developer to start it all and run one assay, one blood test, and then quickly shut it all down. So similar to that demo I gave you, except you've got more microservices at once, basically. And the test rig that did all that did starting everything, running one assay, and shutting everything down. And then the printer that we used, because, I mean, this web page, you're looking at it and you're thinking, that's not exactly cutting-edge web page design, is it? No. So the styling, the CSS, was completely uninteresting, actually. It was just, what we were really interested in is the data that's on the page correct? So we have a script that will strip out all of the HTML tags, all of the styling, all of the JavaScript, just lays out the actual contents of the page. I think it's probably a bit small to see, but that is exactly the same text that's laid out beautifully in HTML there. But that is an ASCII, a plain text version of that web page. And we've just got a script, it's 150 lines of Python or something, that will just strip out the interesting parts and lay it out in a table that's recognizable to a domain expert. If they've seen that web page, they can look at that text file and think, oh yeah, I can recognize where I am there. And they can check, oh yeah, that assay result there isn't being, we're missing a field, or that field's not formatted in the way that the user expects. So this was a very successful way of putting regression tests around the functionality to enable the the microservice transition to go much more smoothly. So that was one case study. This is another one, cloud invoice service. This was bigger scale. We had about 60 microservices at the time. I think that they've got hundreds and hundreds now. But again, it was a monolith to microservices transition that we were in the middle of. And it's the main thing that this thing does is it has an API that sends and receives invoices. And it's a multi-tenant cloud service. So there's an invoice there. It's a PDF. So it's this service that is receiving and sending invoices from all different kind of business parties. So we had to make some architectural changes for testability. We did have a test environment. I know the last talk said you shouldn't kind of have test environments somehow, but we did. We had a shared test environment that we deployed everything in. And then a custom API that we built so that you could set up. So it wasn't, because we weren't restarting the system between tests, it was there, it was up. We partitioned and isolated the tests by customer. This was a multi-tenant system. So one of the features of this is that every customer should only see their own data. And we just took advantage of that so that the test would create a customer and then it would have its own world inside that system, isolated from all the other tests. And it worked mostly. It wasn't as good isolation as we got with the previous approach, but it worked well enough. And then the other thing we set up was a tracing ID so that the test would initiate a document processing, and then that would jump between microservices, and we would send with it the same ID so that the test at the end could get a trace of what services got hit by this test case. And it was following all the events that were generated. So that was so the main approved file was the invoice that came out at the other end from the API. And again, we had a printer that would just make that into plain text. And that's a Unix utility, actually, PDF to text. And then the other thing we were checking was the event log. So that was mostly for debugging purposes, so that when the PDF was different, we would then look at, well, what's the diff on the event log? We missed this event, or this event was wrong, or this event, came twice, So that was how we would work out what went on. So then I think I've got time, hopefully, for the third case study. Again, so this was a crew planner. So this was a monolith, kind of, monolithic, rich client Java front end with an optimizer and rules engine written in C++ in the back end, but it was all deployed on one machine, the front end and the back end, actually, and then it was talking to an Oracle database that was somewhere else. And that's a screenshot of it. So, as I said, a rich client, really, really detailed graphical representation of a plan for airline crew. You've got 3 crew there, flying from Copenhagen or Oslo. This is all their duties. So it's like a Gantt chart of what each person is supposed to do when they're on duty. So we again had to make architectural changes to make this thing testable. We went for the running many instances in parallel again. So we needed to be able to start the whole thing up really fast, we replaced the Oracle database with an in-memory database because Oracle was just too slow. It might be better now. This was quite a while ago. And then we had developed our own scripting language for driving the GUI so that we could drive the user interactions with planning the crew. So this was, that was enough of an investment just to do all these architectural changes so we could just start it up, run a scenario, shut it down, and check what happened in the database. And then the printer, this was also a huge job. So this, in the background there, that's the GUI I showed you earlier. In the foreground, that's the ASCII art printout of the same GUI. So we basically wrote a program that could take all the Java widgets and have them all render as text. So, and the colors were really important here. So when it says that the blob in there is green, it actually writes on the printout, there it says green. This is a green line, another green line, and there's a brown line and a blue line. So it's actually really detailed. The thing is, this was quite some time ago. I wonder if today we would have tried it with image diffing, because the tools today are actually pretty good for image diffing. But this was quite some years ago, and the investment in this ASCII art, actually, I mean, you can version control ASCII, you can diff ASCII, you can do a regular expression search and replace. It's actually very convenient to have plain text. So it would still be my first choice, actually, over image recognition, but it was a lot of work. So that was 3 different applications that I've used an approval testing approach on, and the approach was the same. You've got to do some upfront architectural work to make those, pull out those drawers, make it possible to test this way. Then you've got to write the tests, and then hopefully you've got the situation you wanted, where you can do that refactoring. So the tools I've shown you are approvals. That was the first demo. Text test. That was the second demo. Tuka gets an honorable mention. I haven't used it much, I have to say, but I believe it's particularly useful if you've got a lot of data. So worth checking out. They're all open source. And yeah, so that's what I would like to leave you with, really. If you've got legacy code, see if you can have a go with some approval testing. And hopefully, if you get a good collaboration with your architects and your testers, you can be successful with this and get your legacy code under control. Thank you.